Welcome to our deep dive into the fascinating world of ancient Chinese astronomy.
Oh, yes.
We're going to be kind of exploring this really interesting text.
Okay.
It's called the Zhou,
Hmm.
and it's basically this compilation of astronomical observations and mathematical methods that ancient Chinese astronomers used.
Yeah.
And it's unlike anything you've probably seen before.
It really is, yeah.
Yeah.
Um, while, like, everyone always talks about ancient Greek astronomy, it's
Yeah.
always taking center stage,
Right.
uh, the Zubi is like a totally different approach.
Yeah.
It's rooted in terrestrial observation.
Right.
And it has this, like, really unique cosmological model.
Yeah, and for this deep dive, we've got a few different sources to help us out.
Okay.
We've got Astronomy and Mathematics in ancient China, just for like context,
Yeah.
And then we've got excerpts from the Zhubi itself,
Okay.
and then also a variety of different scholarly articles to help us connect all the dots.
Yeah, that's great.
And I know you're particularly interested in how ancient Chinese astronomers viewed the universe and how they calculated celestial movements and used instruments like the gnomon.
Yeah.
And trust me, the way they approach these questions is super fascinating.
I bet, yeah.
So one of the first things that you'll notice when you look at the Zhubi is its emphasis on this thing called Gaishian cosmology.
Okay.
Which basically translates to like canopy heaven.
Mm-hmm.
So imagine this. You've got a flat Earth, and it's covered by this like dome-shaped heaven
Wow.
that's rotating around a central pole.
Okay.
So that's like the essence of their model.
Now, the idea of a flat Earth, might seem kind of odd to us today.
Yeah.
But, it's important to understand that back then, their observations and understanding of the world were just different.
Yeah.
And what's really amazing is that they achieved, like, surprisingly accurate calculations,
Mhm.
even though their model was so different from ours.
Yeah, and so this model, it's not just like a simple description.
Yeah.
The Zhubi actually goes into specifics.
Oh, cool. They talk about these things called hang circles.
Okay.
And you can think of these as like these celestial tracks.
Okay.
They mark the sun's path.
Mm-hmm.
So it's kind of like our tropics and equator,
All right.
But there's some key differences.
Okay, cool. So they're like mapping out the sun's movement, throughout the year.
Right.
But how did they actually like measure and calculate these things?
Well, that's where the gnomon comes in.
Oh, yeah. I was curious about that.
Yeah, so the gnomon, it's this simple vertical pole,
Okay.
and it played like this super central role in their astronomical observations.
Okay.
So by like meticulously measuring the length of its shadow at different times,
Mm-hmm.
they could figure out the sun's height,
Uh-huh.
the distances to different celestial bodies,
Yeah.
and even the diameter of the universe, according to their model.
Oh, wow. So like this like simple tool allowed them to gather so much information.
It really did, yeah.
That's amazing. And it makes you think, like, how did they view the relationship between, like, these earthly measurements
Yeah,
and the grand scale of the cosmos?
that's a good question, and that's where things get really interesting.
Yeah.
Because, the Zubai's calculations weren't just about, like practical astronomy.
Right.
It was like deeply connected to their philosophical beliefs
Right. Yeah.
about like the order of the cosmos and the emperor's role in maintaining this harmony
Yeah.
between heaven and earth.
Right. And there's that great opening dialogue
Yeah.
between the Duke of Zhou and Shangao
Yeah.
that really highlights this beautifully.
I love that part.
Yeah. You know the part where the Duke asks,
Mm-hmm.
like, how can we know the dimensions of heaven if
Yeah.
we can't physically measure them?
Right.
And Shangao is just like, well, the patterns for these numbers come from the circle and the square.
It's like they're saying that the same geometric principles that we see on earth are mirrored in the heavens.
Exactly.
Yeah.
It's amazing. And this idea that there's this fundamental order that underpins both the earthly and the celestial,
Yeah.
it like permeates the entire Zhubi.
Wow.
And we even see it like echoed in section #A,
Okay.
where they talk about the square and the circle as like the fundamental shapes of the universe.
It's like setting the stage for their whole approach to astronomy.
Exactly. Yeah, and it's not just about like charting stars or planets or whatever.
Yeah.
It's about uncovering this deeper, more fundamental order
Yeah.
that governs the entire universe.
And this philosophical layer adds a whole other dimension to their astronomical calculations.
It really does. And then there's also this connection to the emperor's role, which is also fascinating.
Yeah.
So like celestial events,
Yeah.
things like eclipses or comets,
Mhm.
they weren't just like astronomical phenomena to them.
Right.
They were seen as like these omens
Oh, wow.
that reflected the state of affairs on Earth.
Almost like a performance review for the emperor's, ability to maintain harmony.
Exactly. And so being able to predict these events was super important.
I bet,
It
yeah.
wasn't just about reacting, it was about demonstrating that the emperor understood the cosmos
Yeah,
and that he was able to ensure order.
right. So that's why the Zhubai spends so much time explaining its methods for
Yes.
calculating these celestial movements and,
Yeah,
developing this reliable calendar.
exactly. And speaking of calendars,
Yeah.
the Zhubai also talks about the lunar calendar
Okay.
and this challenge of intercalation.
Right.
So you've probably noticed that like a purely lunar calendar
Uh-huh.
doesn't quite sync up with the seasons over time.
You're right.
Yeah, it's a problem.
A lot of ancient cultures had this problem.
They did, yeah.
They had to figure out how to reconcile the lunar calendar with the solar year.
And the Zhubai tackles this head on.
Oh, cool.
So they provide these really detailed calculations for the mean lunation, which is
Yeah.
like the average length of a lunar month.
Okay.
And they lay out these different methods for inserting what they call intercalary months,
Uh-huh.
which is basically like adding an extra month every few years.
Oh, okay. So that's how they kept the lunar calendar in sync with the solar year.
Exactly. And it's interesting to think about
Yeah.
how other ancient cultures tackled this problem,
Yeah.
because this must have been something that everybody was dealing with.
Right. Were their approaches similar, or did the Zhubai come up with something totally unique?
That is a great question, and honestly, I don't have the answer to that right now.
Yeah.
But while the need to reconcile these lunar and solar cycles was definitely universal,
Yeah.
the specific methods that they used,
Mhm.
they definitely varied from culture to culture.
Right.
And the Zbai's approach, which is based on like detailed observations and a very keen understanding of these cyclical patterns,
Yeah.
it really reflects this distinctive blend of mathematical sophistication and their underlying philosophical principles.
Fascinating.
Yes.
But I have a question. If they believed in a flat Earth, wouldn't that mess up their calculations for things like, how long a year is,
Yeah.
or the distances to celestial bodies?
That's a great question. And it's a natural one to ask.
Yeah.
And it leads us to one of the most intriguing parts of the Zubi,
Oh, really?
which is its ability to achieve this like remarkable degree of accuracy
Wow.
in its predictions, even though they were adhering to this Gaussian model.
Yeah.
So they were very meticulous observers
Mm-hmm.
and brilliant mathematicians, and they were constantly refining their model to account for any discrepancies.
So it wasn't like a static model.
It wasn't, no.
They were like constantly refining it
Yes.
and adapting it based on their observations.
Exactly.
Can you give me an example of how they did that?
Absolutely. So one example is their introduction of this mysterious celestial feature.
Okay.
It's called the suanjing circle.
The suanjing circle.
Okay.
Yes.
We'll talk about it in more detail later, but
Yeah.
it's this fascinating concept that really highlights their willingness to kind of adjust their understanding
Yeah.
as they encounter new information.
This is already so intriguing.
Yeah.
It seems like the Zhubai isn't just like a straightforward astronomy textbook,
Yeah.
It's like this window into this complex system of knowledge
Yes.
that blends their observations with their calculations and their philosophical beliefs.
Exactly. And as we continue, we're going to uncover even more surprises and insights.
Awesome.
So, for example, their unique approach to measuring the heavens using this thing called a graduated circle.
Yeah.
It reveals this completely different way of thinking about angles and distances
Cool.
compared to like Western
The
astronomy.
graduated circle, so they weren't using degrees like we do.
They weren't. No, it's fascinating.
It is.
And I'm really starting to see how the Zhubai offers this unique perspective on astronomy.
Yeah.
Like blending practicality with philosophy and their own unique methods.
It certainly does. And we haven't even talked about the philosophical implications
Right.
of the Zhubi, which are just as fascinating.
Yeah, like that opening dialogue between the Duke of Zhou and Shengao.
Yeah.
It hints at this like deep belief
Uh-huh.
in the mathematical patterns that like underlie the entire cosmos.
Wow. So it's not just about mapping the stars. It's about understanding like the essence of the universe.
Exactly.
It's amazing.
It is.
Well, I can't wait to dive in.
Yeah, me too. So stay with us as we continue this deep dive into the Zhubi and the world of ancient Chinese astronomy.
I'm ready.
We've got even more fascinating insights to share.
Can't wait.
So we were just discussing how the Zhubai blends like practical astronomy with all these philosophical ideas.
Yeah, it's really...
It's not just about, observing and calculating.
Right.
It's about understanding the universe.
Yeah, on this deeper level.
Yeah, exactly.
Like trying to figure out like the big picture.
Yeah, and that philosophical framework is like super evident in their cosmological model, which is the Gaitian.
Yeah, canopy heaven.
Yeah. Yes, and as we talked about earlier, it envisions this like flat Earth with a dome-shaped heaven rotating around a central pole.
It's such a cool image.
It is.
I can just picture it.
Yeah, and it might seem simplistic from a modern perspective.
Yeah.
But it was based on...
like careful observations.
Yes.
Trying to make sense of the world.
Exactly.
And they were able to make some like really accurate predictions.
They were.
Based on this model.
But remember you mentioned earlier that there were some like discrepancies they had to account for?
Oh yeah, like the suanjing circle.
Yes, exactly.
That's one of the most intriguing parts of the Zhou.
It is.
It's like this big debate.
Yeah, and to understand it, we have to go back to their calculations of the sun's path.
Okay.
So their model initially suggested that the sun's rays would reach the north celestial pole at the equinoxes.
And that's what Chenzi explains to Rongfeng in the Zhou, like predicting 6 months of daylight followed by 6 months of darkness at the pole.
Exactly. But as they refine their calculations, they realized this wasn't totally accurate. And so they introduced this suanjing circle, which is this like smaller circle around the pole, to explain why there wouldn't be continuous daylight or darkness for 6 months at a time.
That's fascinating. So they were constantly testing their model against their observations and making changes as they learned more.
Exactly. They weren't just like rigidly sticking to a theory.
Right. It was about refining their understanding.
Yes, and what's even more fascinating is that the suanjing circle, it's not just like this mathematical abstraction. It's described as this like physical feature of the heavens. And they use it to explain like polar phenomena and tropical climates.
So they were trying to incorporate reports from travelers who'd been to the far north and seen daylight even during the winter solstice.
It's amazing.
Instead of just dismissing those reports, they tried to figure out how to fit them into their model.
Exactly.
That's so cool.
Yeah, and they even tried to explain like tropical conditions.
Oh, wow.
With their long days and intense heat through the position of this suanjing circle.
They were really committed to incorporating new information.
They were.
And refining their model.
Yeah, and even though they were working with this different cosmological model, they were still asking those like fundamental questions that astronomers have always asked.
Yeah, like how does the sun's path affect different parts of the Earth?
Exactly.
How do we make our models match what we see?
Yeah, and their answers might seem strange to us today.
Yeah, they probably do.
But they reflect this like deep curiosity and a willingness to adapt.
Which is so important for scientific inquiry.
Exactly. And speaking of adapting, our sources mention that the Zhou itself isn't like a single unified text.
Oh, what do you mean?
It's more likely like a compilation of different texts written by various authors over time.
Interesting.
Yeah, and this helps explain why there are some inconsistencies.
Right.
And even contradictions within the text.
Right, because different sections could reflect different perspectives and different stages of development in their astronomical knowledge.
Yeah, and it also explains why some sections seem to have like no connection to other sections. Like, for example, section #A with its discussion of the square and the circle as the fundamental shapes of the universe.
Right.
It feels very different from the detailed astronomical calculations in other sections.
Exactly.
And then you have section #C, which is exploring this relationship between the circumference and diameter of a circle.
That sounds more like math.
It does, yeah. It almost feels like a mathematical treatise. Right. More than an astronomical one.
Yeah, and then there's section #B.
Yes. The Book of Chenzi.
Yeah.
Which lays out like the core principles of the Gaitian cosmology.
So it's like the foundation for a lot of the calculations.
Exactly, or in other sections.
So instead of seeing the Zhou as this like single coherent textbook, it's more accurate to view it as a collection of related but distinct texts, each offering a piece.
A piece of the puzzle.
Yes, of the puzzle of ancient Chinese astronomy.
So the Zhou isn't just a snapshot in time.
No, it's not.
It's like a window into how their astronomical thinking developed.
Exactly.
We can see them grappling with new observations.
Yes.
Refining their models.
Right.
Incorporating new information.
And it challenges us to reconsider our own assumptions.
Oh, yeah.
About what scientific knowledge actually is.
That's a good point.
Yeah. And one thing that's really striking to me is how their approach to angles and distances is different from ours. Right.
Like we rely so much on angles and trigonometry.
Yeah, we do it in modern astronomy.
Yeah. But the Zhou doesn't use angles in the same way.
Oh, so what do?
Their methods focus on linear distances and ratios.
Okay.
And this is really evident in their use of the gnomon and the graduated circle.
I was wondering about that.
So the Zhou has tons of examples of how they use the gnomon. And the graduated circle is another fascinating example. So it wasn't divided into degrees like ours is.
Oh, so how'd it work?
Each division on their circle represented a specific length.
Oh, okay.
Along the circumference.
So they used those lengths along with the gnomon's shadow to figure out distances to celestial bodies.
Yes.
And the angular extent of the 28 lunar lodges.
Exactly.
Oh, wow, that's cool.
And these lunar lodges were like key reference points in their sky mapping.
So it seems like their idea of an angle was always tied to a specific length.
Yes.
It was more concrete.
Yeah.
More earthbound.
Exactly. Which makes sense considering their flat Earth.
Yeah.
And dome-shaped heaven.
Their cosmology and mathematical methods were very grounded in their everyday experience of the world.
Exactly. And despite this different approach, they were still able to contribute.
Contribute to astronomy.
Yeah, like a lot.
In really significant ways.
Their observations and calculations laid the groundwork for later developments.
In Chinese astronomy.
Yes. And even today, their insights are fascinating.
Absolutely. They're so inspiring.
And the Zhou wasn't just forgotten about after it was compiled.
What happened to it?
It was studied and copied and commented on for centuries.
Wow, so we have like commentaries that give us insights into how the Zhou was interpreted.
Exactly. Like, for example, we have the commentary by Zhou, who was this 3rd century AD scholar. And his work is credited with preserving and explaining a lot of the Zhou's key passages.
Oh, wow. So he's like our link
to
how the text was understood back then.
Exactly. And his commentary is essential for anyone trying to understand the Zhou today.
I bet.
He clarifies all these like obscure passages.
Oh, that's helpful.
Provides additional diagrams and explanations.
Wow.
And he deepens our understanding of the text's historical context.
That's amazing.
And there were other commentaries as well.
Oh, really?
Yeah. So later scholars like Li Chunfeng in the 7th century and Daizin in the 18th century, they added their own interpretations and insights.
So it wasn't just a relic of the past.
It wasn't.
It was like a living document.
Exactly.
That people kept studying and debating.
Yeah, for centuries.
That's incredible.
It's a testament to the enduring influence of the Zhou and the long and rich history of Chinese intellectual tradition.
It wasn't just about astronomy.
It wasn't.
It was part of this bigger conversation about the universe and our place in it.
And speaking of the universe, we can't forget about the moon.
The moon, right.
The Zhou pays a lot of attention to the moon and its movements.
Well, that makes sense.
It does.
Given their lunisolar calendar.
Exactly. Their calendar was based on both the cycles of the moon and the sun, which means they had to carefully track the moon's phases and its position relative to the stars.
And the Zhou gives instructions.
It does.
For calculating all of that.
Yes. So like the moon's daily motion, the length of a lunar month, and even the timing of eclipses.
Which were super important to them.
They were. And remember, they used intercalation to keep their calendar in sync with the seasons.
Yeah, adding those extra months.
Exactly. And their calendar wasn't just a way to track time.
Right. It was more than that.
Yeah, it was this sophisticated system for reconciling the cycles of heaven and earth.
Wow.
Blending their observations with their philosophical understanding of the cosmos.
Their lunar calculations really show.
They do.
Their observational skills And their mathematical ingenuity.
Yes, and they were able to create this calendar that reflects their understanding of the interconnectedness of the celestial and terrestrial realms.
It's all connected.
It is, and as we continue this deep dive, it's becoming clear that the Zhou isn't just about astronomy or mathematics.
Right.
It's a reflection of a broader worldview.
Okay.
A way of understanding the cosmos and humanity's place within it.
That's a really important point.
The Zhou is embedded in this philosophical framework that emphasizes this interconnectedness of heaven and earth, the importance of balance and harmony, and the role of the emperor as like the intermediary
between those realms.
Exactly. And their astronomical observations weren't just about
acquiring knowledge just for the sake of it.
They were seen as essential for maintaining order and stability in society.
So observing the heavens was a way of understanding the patterns that govern life.
Yes.
Like the cycles of nature, the fate of dynasties.
Exactly. And so for them, astronomy wasn't this separate discipline.
Right. It was all connected.
Yes. It was interwoven with politics, religion, and everyday life.
The Zhou really gives us a glimpse into this worldview.
It does, with its blend of astronomical observations, mathematical methods, and philosophical reflections.
It shows us how interconnected knowledge was.
Exactly. And their astronomical knowledge had practical applications.
Oh, like what?
So like creating a reliable calendar for agriculture.
Oh, that's important?
It is. Yeah. And providing guidance for rituals and state affairs.
Wow. So it wasn't just the emperor and his court astronomers who were interested in these things.
It wasn't, no. And our sources indicate that there were astronomical experts.
Really?
Among the common people as well.
So there were like amateur astronomers?
Yes, exactly.
That's cool.
Yeah, and the Zhou itself might have originated
from
a group of scholars outside the official astronomical bureaucracy.
So they were just studying the heavens on their own.
Yeah, developing their own models and calculations.
Wow.
And contributing to this shared body of knowledge.
So there was this tradition of amateur astronomy.
Yes.
That's amazing.
It's like they saw the sky as this shared text, this source of knowledge and wonder that was accessible to anyone who took the time to observe it.
That's beautifully put.
Thank you.
The Zhou really is a testament to this human fascination. With the cosmos.
Yeah.
It shows us the blend of sophisticated calculations and philosophical reflections that characterize their approach to understanding the universe.
You know, it's amazing to think
it is
that people were exploring these astronomical ideas centuries ago.
Yeah.
And what's really remarkable is how accurate the Zhou predictions and calculations are.
Yeah, like how did they do that?
I know, it's incredible, right?
Especially with a model so different from ours.
Exactly.
It really shows, how dedicated they were.
Yeah.
As observers.
And their ingenuity in developing these mathematical techniques to make their model work.
To make it all fit together.
Yeah. And they weren't afraid to challenge their own assumptions.
Right.
And to refine their understanding.
As they got new information.
Exactly. And that spirit of inquiry and adaptation, that's what drives scientific progress.
That's true.
No matter what model you're working with.
Right.
And the Zhou legacy goes beyond just the astronomical content.
What do you mean?
It's a testament to human curiosity.
Oh, yeah.
To the ingenuity of these ancient Chinese scholars.
Yeah.
And to the value of approaching knowledge from multiple perspectives.
Right. Thinking outside the box.
Exactly.
Challenging your own assumptions.
And the Zhou offers us this window into a way of thinking that saw the universe as this interconnected and harmonious whole.
It wasn't just about, mapping stars and planets. It was bigger than that.
Yes, it was about understanding.
Trying to figure out.
Yeah, like the underlying principles that govern everything.
Yeah, our place in it all.
And those astronomical pursuits weren't isolated.
Right, they were all connected.
To their beliefs about the emperor, the importance of social harmony, the connection between heaven and earth.
Exactly.
It was all intertwined.
Studying the heavens wasn't just science. Right. It was a way of life.
Yeah, it was a way of understanding reality.
And making sure society was functioning well.
So as we wrap up our deep dive into the Zhou, I'm just struck by the ingenuity and intellectual curiosity of these ancient Chinese astronomers.
They were amazing.
They really were.
Working with such different tools and models than we have today.
But their dedication to observation, their willingness to adapt, and their quest to understand the universe.
It's inspiring.
It really is.
It's a good reminder that there are lots of different ways to understand the universe.
And even these ancient texts can offer valuable insights and challenge us to think differently.
To see things from a new perspective.
Exactly. So for you, listener, what does all of this mean?
Well,
we've explored this unique cosmological model. The Zhu's intricate calculations, the philosophical underpinnings, and its lasting legacy.
What do you think it all means?
Well, I think it challenges us to broaden our perspectives, to consider different ways of knowing and understanding.
Different ways of thinking.
Yes, and to appreciate how interconnected knowledge can be.
Wow. Across time and cultures.
Exactly.
It's amazing.
And I think this deep dive leaves us with a question.
Oh, a question.
Yeah, to ponder.
What is it?
So, given the Zhu's emphasis on terrestrial measurements and its distinctive model of the cosmos, how do you think this might have influenced the development of mathematics and other sciences?
Interesting.
In ancient China.
Yeah. It makes you wonder.
It does.
What impact it had.
It's a question worth exploring.
Definitely.
And with that, I want to encourage you to continue exploring ancient Chinese astronomy.
Yeah, there's so much to discover.
There is countless treasures. From intricate star charts and instruments to philosophical and literary works.
It's a whole world out there.
It is a world that reflects this profound wonder at the universe.
So keep exploring.
Yes, keep questioning.
And keep diving deep
into this vast ocean of knowledge.
Until next time.
Yes.
Keep looking up.
And keep asking those big cosmic questions.
You never know what you'll find.
Exactly.